Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see electrical supply system. This question is very important in this particular unit, where this can be asked in sure 12 or 16 mark question, and this is very basic information about electrical supply system. You have to understand how the electrical supply system works, how the power is generated, how it is transmitted, and how it is distributed to the consumers. So we will see everything in this particular video. So it's all about electrical supply system. When you say electrical supply system, you can see these diagrams where the supply system is nothing but it starts from generation to distribution. That is, the power is generated and then it is transmitted through overhead cables, and then it is distributed to the consumers. So we're going to see what are the different processes that is involved, right? And before starting this video, you have to be very clear with this concept, where you got to understand what is primary transmission, what is secondary transmission, what is primary distribution, what is secondary distribution, and then you got to understand what is feeder line, what is distributor line, and what is service lines. All these are very important concepts, right? So when it comes to electrical supply system, I'll explain everything in this particular slide, right? From this slide, you can understand the complete electrical supply system. So when you say power plant, first the power plant is normally will be placed in very remote areas, right? Remote areas in the sense where there is resources for generation of power. Say for example, in Tamil Nadu you have Neyveli, where you have Neyveli power station, where you have the natural resource, coal is the natural resource which is found there in that particular area. So the power plant is situated in that particular place. So the power plant normally will be located in very remote areas where there will be the resources for power generation is high, right? And from power station, from power plant, normally generates power. We generates power. The power will be normally around 11 kilovolt. Right? And I'll just explain you the complete structure first, and then I'll come back to this particular voltages, right? So the generated power from the power plant will be transmitted through overhead cables. Overhead cables, OH cables, where we know that the power plant is located in the remote areas. From that remote areas, it has to be transmitted to the main load centers. Main load centers. You have to be transmitted to main load centers. So from power plant, first thing it will be step up. The voltage which is generated, it will be stepped up to a very higher voltage by using a step up transformer, and that higher voltage will be transmitted through these overhead cables, right? And through this overhead cables, it will reach this particular main load center, right? Some areas which is very near to the cities, right? This will be a main load center, right? And from this main load center, it has to reach the inside the cities, right? So from this main load center, it will be transmitted to another substation. This is subload center. We call it as subload center. Subload center, right? And even here, before transmitting to the subload center, the voltage will be stepped down. It will be stepped down. It will be stepped down. And again, after reaching the substation, once again, it will be stepped down and sent to the distributors. These are called distributors. These are called distributors. So again, there will be step down here. There will be step down here. Step down of voltage. And from this distributor, it will be transmitted to the humans, that is the consumers, to every home. And again here, it will be a step down operation. The voltage will be stepped down. I'll come back to these voltages, but this is the complete working. The power is generated in the power plant, and then it is transmitted to the main load center, right? The transmission here will happen at high voltage. That's because for high voltage, you have a lot of advantages, like it requires minimum conductors. We will see all those things, right? And then from main load center, it will be transmitted to subload center. right? And from subload center, it is distributed to the homes. This is the complete structure, right? Now, when this is the complete structure, you will understand what is primary transmission, what is secondary transmission, what is primary distribution, and what is secondary distribution, right? And in that case, you will understand here the power that is generated, that is transmitted to this particular main load center, right? Main load center. So this is called as primary transmission. This is called as primary transmission. And from this main load center, it is being transmitted to the subload center, right? And this is called as secondary transmission. This is called as secondary transmission. This is called as secondary transmission. And from this secondary transmission, now this is called as distribution substation, right? And this is the subload station, subload center. From here, it is transmitted to this particular distributors, right? So this distributor, this particular part, this is called as primary distribution. This is called as primary distribution. That is distributing the power from the substation to the transformer which is in the streets, right? Which is in the streets, right? Nearby streets, from the main streets. That is called as primary distributor. And from this main street, it will be sent to the substreets, right? From main street, it will be substreets. Where from substreets, you will have a service line to your homes, right? So this part is called as secondary distribution. Secondary distribution. Right? So now you understand what is primary transmission, what is secondary transmission, primary distribution and secondary distribution. Right? From power plant to the main load center, that is called as primary transmission. From main load center to the substation, that is secondary transmission. From this substation to the transformers in the main streets, that is called as primary distribution. And from that to the home, that is secondary distribution. Right? And for all this operation, you will understand there is only one step-up transformer that will be used, right? So that is used at this particular place, that is in the primary transmission. When the power is generated, it will be stepped up to higher voltage and it will be transmitted, right? That is, the power will be normally generated at 11 kilowatt, right? You have a lot of voltages, but remember any particular voltage and stick to that so that you can explain the complete structure with that particular voltage. So the power is generated at 11 kilowatt and now it is sent to the step-up transformer before transmitting through the overhead cables, right? So it will be stepped up to around 230 kilowatt, right? And this is the only step-up transformer, whereas after this, in the complete electrical supply system, you will have only step-down transformer. Right? So now this reaches, this 230 kilovolt reaches this particular main load center. So in this main load center, it will be step down operation. There will be a step down transformer which converts this 230 kilowatt into 33 kilowatt. Right? And from this 33 kilovolt, when it reaches the substation, and again here there will be a step down transformer which converts this 33 kilovolt into 11 kilovolt, right? When it reaches the primary distributors, it will be 11 kilovolt, and there will be number of primary distributors which is connected, and then it is being sent to the consumers, right? It will be sent to the another transformer which is near to the street, right? Which is near to the home, right? The substreets, right? Where again on this here, this 11 kilovolt will be converted to 415 volt or 230 volt depending upon the consumer needs. If it is single phase, it will be converted to 230 volt, and if it is three phase, it will be 415 volts. So you all understand here that is power generated at 11 kilovolt, and then it is transmitted by step up operation, where it is transmitted to primary transmitter, right? Primary transmission, where it reaches to 11 kilovolt, 230 kilovolt, and from main load center it reaches the sub load center where this is converted to 33 kilovolt. It is again a step down operation, and from 33 kilovolt it reaches the distributors with 11 kilovolt, right? And from 11 kilovolt it reaches the consumers. Again it is stepped down to 415 volts or 230 volts depending upon the consumer need. So this is the complete picture of electrical supply system, right? And here you will understand the lines which we used. That is here for primary transmission, right? And even till the substation, right? You will use mostly overhead cables. Overhead cables, right? Overhead cables is nothing but the lines which carries this 100 volt, 100 kilovolt, which carries this 230 kilovolt, right? This overhead, right, above the head transmission lines, right? And overhead cables are little less expensive when compared to underground cables, and these are remote areas where outside the cities. So mostly we prefer overhead cables, whereas inside cities we prefer underground cables, right, because of safety reasons, right? And another thing you have to understand here is you have to understand different lines. You have to understand here what is distributors. So if you see here, from this distribution to this particular, these are called as distributors. These transformers are called as distribution transformers. We call this as distributor transformers, right? And this line from the substation to this distributor transformer, that is called as feeder line. That is called as feeder line, right? And this particular transformer is called as distributor lines. Whereas from this distributor to the home, it is called as service lines, where we get service from the local transformer which is near to our home, right? That is service line, right? So this is the complete picture of electrical supply system, right? This is the simple layout of electrical power system which I just explained, right? So you can see here the power is generated at 11 kilowatt, right? From 11 kilowatt it will be stepped up and it is transmitted through the overhead cables, right? It reaches the main load center, right? It reaches the main load center which is stepped up to 230 kilowatt. You can see here from 11 kilowatt it is stepped out and reaches the 230 kilowatt, and this line is called as primary transmission line, right? Primary transmission line, where this is the main load center, and from main load center it is sent to the sub load center, where these we call this as step down transformer, and this is a secondary transmission line, right? And the 230 kilowatt is converted again to 33 kilovolt, right? From main load center to sub load center, from sub load center, right? And from sub load center, right, what happens from sub load centers, it is given to distributors, correct? From sub load center to the main cities, right, where again we use a transformer to convert it to 11 kilovolt. Whatever we saw in previous slide, I'm just explaining the voltages here, right? So from substation it is sent to the distributors, right, where again it is converted to 11 kilovolt, right? And this is called as primary distribution. We call it as primary distribution, right? And from this transformers, right, from this particular primary distribution, the secondary distribution will take place from distributor to the consumers, right? And again this 11 kilovolt is stepped down to 415 or 230 volts. 415 is for 3-phase, whereas 230 is for single phase, right? So this is the complete structure of electrical power system. So whatever I explained, that is what given here. As I said, the power stations will be normally in remote areas where resources for power generation will be more and available at plenty, right? The transmission of electrical power is done at high voltages. That is because of several advantages. We call it as electrical supply system. That's because it combines generation, transmission and distribution. Generation, transmission and distribution, right? When we say power generation, as I said, the power is generated at 11 kilovolt and it has been stepped up by using high power transformer, step up transformer, and it is stepped up to 110 or 230 kilovolt, right? And then it is transmitted to the main load center, right? And this main load center, the power transmitted at the generated at the power station, that has been transmitted to the main load center at 400 kilovolt, right? And this transmission is called as primary transmission, and most of this will take place through overhead lines. And why is that we use high power for transmission? That's because the volume of conductor materials required is low. That is very much important, right? And then another thing is, for the given amount of power transmitted, the current through the line is reduced and the efficiency will be increased. And the third important point here is, as the current is reduced, the voltage in the line is reduced. The line regulation is improved. So for regulation of lines and for the need of low conductor materials, right? And also the efficiency can be increased. For these reasons, we transmit the power generated through the overhead cables at higher transmission voltage, right? And from main load center, it is sent to the subload center, where we call it as secondary transmission system, right? And normally till primary transmission system we will use overhead cables, whereas for secondary transmission system, right, we will start using the underground cables, because when it reaches city, safety plays a very vital role, right? And now after reaching the substation, it's all about distribution, right? So again, from substation, it has been reduced to 11 kilovolt. It is stepped down to 11 kilovolt, and it is sent to the distribution lines, which is along the streets, right? The main streets, which we call it as distributor, right? And from there, it is sent to the public for the consumers, where by using 4-wire line cables or single phase cables, where for 3-phase it will be 415 volts and for single phase it will be 230 volts. Right? And the power will be distributed from the distributor to the consumers using service lines, whereas the feeder line from the substation to the distributors, that is called as feeder line, right? You can see this one. These are called distributors. These are called distributors. From these distributors, it is sent to these are called service lines. These are called service lines. And you can see from substation, right, the wire which is used to distributors is called as feeders. So you will understand the difference between distributors, feeders, and as well as the service lines, right? And the components that is used for transmission and distribution system is conductors. What is conductors? You can see these lines, right? These lines you would have seen in your streets, right, where you have this aluminum lines. Mostly you will use aluminum or copper, right? Aluminum lines where used to carry the electrical power from one place to the another, right? These are called conductors, right? And then we have this particular cemented RC, reinforced cement concrete, right? This is poles, and these poles can be of different types, where it can be RCC poles or towers, right? Or it can be of any type, right? And these are used to keep the conductors at proper height. Only through these poles we make the conductor to go at a proper height from ground, right? And then these transmission lines, these conductors are separated, like different lines can be done by using this cross arms. This is called as cross arms. This is the cross arms which supports the conductor, which segregates different lines, right? And very important part is insulator. You can see, you would have seen this in every transformer, the brown part, that is called as insulator. Whereas this insulator is the one which separates, which isolates this conductor from this particular pole, right? From this particular pole or from this particular cross arms, right? So this insulator is very, very important, right? And apart from it, you have other components as well, lightning arresters, ground wires, stay wires, etc. These are the main components of a transmission and distribution system, right? So we have seen the complete electrical supply system so far, right? And as I said, we will use both overhead cables and as well as underhead cables. So we'll see the comparison between the overhead and as well as the underhead systems. Whereas overhead cables are mostly used in remote places and up to primary transmission, right? Whereas the distribution parts And even in the secondary distributions, right, we will start using the underground cables, right? And what is the main reason? What are the different factors that to be considered? The public safety. When you take underground cables, it is preferred because it is less hazardous to the public. And the underground cable is very costlier than the overhead cables, but when it comes to city limit, safety is very important, right? Flexibility. When it weighs overhead cables is more flexible than underground cable system, but underground cable system can be used only for the distribution part, that is inside the city limits, right? Even though it is less flexible, it is more safer when compared to overhead cables. Another one important point is fault identification. When it comes to underground cables, fault identifications or chances of occurring faults is less, right? And even though it is less, and another important thing here is the fault identification will also be difficult in underground cables, but there will be lesser faults when compared to the overhead cable system, right? So overhead cable system may undergo faults very frequently. That's because it is exposed to atmosphere, sunlight, right? And the other thing is appearance. The general appearance of UG cable system is better. Underground cable system is better than the overhead cables, right? As I said, fault identification. Even though the faults is lesser, or the chances of getting faults in underground cables is lesser, but fault identification is very, very difficult, right? Whereas it is very easier in overhead cables, right? And the lifetime of overhead cables is 50% lesser than the underground cables, right? And the maintenance cable, the underground cable system is low, where the chance of fault is less, right? And we have to invest more amount in overhead cables. That's because it is exposed to sunlight, so maintenance cost will be very high, right? And whenever there is faults, that we have to repair it and we have to replace it, right? And interference with communication circuits, this is very less in underground cables because it is buried underground, so interference will be very less. Whereas for overhead cables, the interference will be very high. That's because it is exposed to atmosphere, and where it will have interference with various communication circuits, right? So you have both advantages and disadvantages in both the systems, underground as well as overhead systems. But within the city limit, the economics doesn't play a very vital role, where safety is very, very important. So inside cities, right, inside distribution system, in fact from the secondary transmission system, we start using the underground cables, right? So today what we have seen is, we have seen the electrical supply system, where we have seen the complete structure of electrical supply system, what are the components that is preferred, and what is the difference between overhead and underground cable systems. I believe this video will be very useful for you. Thank you, my dear students.